My name is Brian Schlining. I am a senior software engineer at the Monterey Bay Aquarium Research Institute. And what we do there is we specialize in deep sea research. We're set up so we have partnerships between scientists and engineers to develop new technologies to explore the deep sea. What we do is we typically operate two remotely operated vehicles, and these are very large unmanned submersibles that are tethered to a ship at the surface. And these vehicles can go all the way down to 4,000 meters in the ocean. And we use these to do scientific research and experiments and just general exploration of the sea. And now each one of these ROVs has a studio quality camera mounted on it. It has a number of cameras, but the main ones are these studio quality cameras. And so when they're underwater, they're recording the entire dive from when it's put in the water, does all its work until it comes back to the surface. And we save all of that video. When it comes back to shore, it's eventually annotated by experts in these particular domains, and they'll go through and identify everything of interest in the video. So you have this huge catalog of video. And the whole idea behind that basically is, typical scientists might go in and they only want to focus on the things they're interested in, and they miss all this, serendipity, all these amazing things that happen. And so our goal is to try to capture all of that and then share that among all the scientists at the Institute. But in order to do that, we have to have software that manages the video and also allows the scientists to annotate it. And that's where I come in. I write all that software to do it. And so right now we manage a catalog of about 30,000 hours of underwater video. Wow. Works out to about 4.5 petabytes of video data.
And you have different systems I've seen. So everything is open source again. It's on GitHub. So I've seen that you have one side, which is server side, to store the video files correctly. And then you have on top a UI?
Yes, that's a bit simpler than it actually is. I wish it was that simple. But we have a very fancy storage system for the back end, but also a number of services, like you identified, that handle different aspects of it. So we'll have a service that handles video annotations. We have a service that manages the video. We have, because we want this to be searchable and consistent, we provide what we call a knowledge base. So it's basically a taxonomy tree of terms that the scientists can use to annotate. And that helps avoid things like misspelling, because a lot of these scientific names are very difficult to spell and keep in your head. And now we're dabbling in the machine learning space. So we're providing services to help augment the data with machine learning generated proposals.
This calls for a demo.
Sure.
I can imagine you have tons of impressive video. So maybe we can have both an impressive demo of the video itself, what you see underwater,
sure,
and then what you've built on top of it.
We'll do this kind of backwards. I'm going to go to the application we're developing to query the data, and that'll let us just see some cool samples.
Yeah,
and then
perfect.
We'll come back and show the tools how we create it. And what I'm just showing here, this is just an internal page at MBARI it basically gives access to all the different services we use for supporting the video annotation. And I'm going to go to this one. We're developing a new query application internally to allow scientists to very quickly find video and research of interest. Now, this isn't a Java app itself, but behind the scenes, it's talking to all Java services that are layered up. We'll search for all kinds of squids, just to illustrate. And the way we structured this, because we have a knowledge base behind the scene, I can search for more than just things that are labeled as squid. I can do all types of squids. And so I've added that. And if I hover over this, you'll see a bunch of names pop up with all the different terms it's going to search for. Let's find something interesting. I want to just find squid that are eating something. And we'll add that to the search. We'll run this. And so these are the results of just squid that are eating something. So we're going to do this. We'll come down and scroll through some results. I'll go to the most recent ones. And here are some, and you can see here's two squids. One is eating the other. I'm going to jump to another one. I'm going to show my favorite animal that I always use for searches. And we're going to go here. I'm going to go look for Episteuthis, which is a kind of also squid. I really like squids, but this one's particularly cute.
A cute squid.
Well, you'll see. So I like this little guy. Kind of looks blobby. Also known as a flapjack octopus. But this is the kind of thing that we, the end result, all this annotation, scientists go through, they add descriptive information. They say, all right, I saw this squid. or this octopus, and it was doing something interesting, and they can add additional bits of information to each annotation. And they're all geo-referenced, so we know exactly when and where we saw each one of these. I'm going to show you one more. There's one more interesting animal that I really love. It's a midwater animal. So when you look at the ocean, there's different regions, you might say.
Mm-hmm.
And so there's the surface waters, of course, and then there's the bottom where a lot of the animals live. But there's this vast space in between. We call it the midwater pelagic space. And it's really the largest habitat on Earth. And that's a tremendous amount of animals live there, but it's also very poorly researched. The cool thing about this critter is you can see it in this image. It's just a small tadpole-like animal, but it builds these tremendous mucus houses. So you can see some of the images that we've kind of gone through it with a laser. So this laser creates a planar sheet, so you can drive the laser through this transparent mucus structure. And we've actually been able to generate 3D models and print these out. So here's a better image of the internal house. You can see there's the head of the tadpole right here. You can't see the tail of the Bathycordeus. And then it's amazing mucus structure that it builds in the internal for collecting food. And here's a really good image of it. There's again, this structure. And then you can see the animal itself is just this tadpole-like animal inside it. And what I'm going to do now is fire up our annotation application. So there's two applications that are involved. This one, Navarre's annotation, is a JavaFX application. For this system to work, it has to talk to a video player. And we have a number of video players written. The video player and this, what we call VARs, talk back and forth to each other just using UDP. And I do have one in JavaFX that's a cross-platform one. I'll just pull that up very quickly. And the way this works is an annotator would come in, they start their session, and this application is customized for each user. So there's a number of users, and as I change different users, my interface would change. But I'm going to open up a video. So I'm going to go here. There's a number of ways to get to a video. One might be, well, I just want to use a browser. And this would basically access the video through the internet, through a web server. So I could browse to a dive of interest. Like I said, we have a lot of dives. And I'm going to bring up just a chunk of that file. And then it brings up in a video player. And I can just start playing the video or scrub along. If I see something of interest, I can just click a button. It creates an annotation at that point in time in the video. So as I can click along, I quickly generate these. If something's wrong, it's very quickly to go back and change it to something else. And so I'm going to type in squid because we like squids. And now it's a squid. Now, one thing I would point out, researchers annotating, it's hard to keep all these scientific names in their heads. So we do allow them to use common names. And you may have noticed that I typed in squid, but when I hit enter to accept that, it changes it to Tithoidea, which is actually, I think, the family name. This is the access for our knowledge base. Just a quick browser.
Super fast.
Well, thank you. Yes. And then if someone's like, well, I want to use these terms a lot, they can just drag them over to their tab, and it'll add them here as terms that they can use quickly to annotate in the future. Most of our staff work on Macs, and so we wrote a video player for Macs, and it has some special features that I want to demonstrate. So I'll open this up, and you can see our beautiful deep sea video. This one has a lot of localizations or bounding boxes. This dive was annotated using machine learning. And so as I play through, let me turn these on, you'll see like little blue flashes.
So this video player is also written in JavaFX, right?
This one is not. This one is written in Swift. And the reason for that is JavaFX does not support ProRes as a codec. So we had to, which is one of the main codecs that we use. So we wrote it using Swift because Apple's AV Foundation supports ProRes very well. Mm-hmm. The reason I was showing this is because not only does it display bounding boxes, but it allows video annotators as they're going along to say, well, I know what this is. I want to create an annotation here. So it'll create an annotation, and it just added over here in vars, and I'm going to change the name of this to, I don't know what that is, but I'm going to call it Sebastolobus. And when I change this here in vars, and I hit enter, it'll actually change it on the video too. And so it keeps the annotations in sync in both places.
Which is really nice. So you have this JavaFX user interface, you have this Swift Apple video player.
Yes.
How do they talk with each other?
So we wrote just a kind of simple UDP protocol. So it sends commands back and forth. If I press play over here, it'll send a play command to the video player, and the player will respond, yes, I received your play command. It also sends some out of bounds commands. So for example, the video player can initiate commands. So when I draw a bounding box here, it has to go back and tell vars that here's a new bounding box. And it also, for example, if I do a frame grab, like if I go along and say, wow, this is the best image, I want to save a copy of this image, I could just click on this button I pressed, and it'll go and grab an image of that frame. And so now I have that image saved. And I have actually two copies. We save one, we have a compressed JPEG and then an uncompressed PNG that we generate. Some other features on this, there's a little timeline. And so when I click that, it shows a timeline of all the annotations across the video from start to end. And if I click on one, it'll select it in the table. And if I double click on one, it'll jump to that point in time in the video. So it allows me to quickly navigate around.
Timeline is very nice. How did you create it? Is it an existing component? Did you create something yourself?
I created something myself. And it wasn't a lot of code, honestly. This is one of the things I really love about JavaFX. It's pretty easy to create your own widgets as needed. So this is all the code for timeline is kind of in this one folder right here. And we have tick marks, which is the vertical. This is the horizontal timeline where you add the ticks to it. Yep. This is just, this is the controller for adding events to the timeline, and then each individual annotation is encapsulated in this bit of code. So you can see it's like there's 4 classes. And let me pick up a different video and I can show you it a little clearer on what it does. So we can see we got the video. There's a lot of ticks down here. I'm going to kind of go to the end of the video. So you can see there's a little red tick on the bar that shows us where we're at in the video. And I'm just going to create a new annotation here, and it appears right away on the timeline, and I can change it to something else, and it just updates it in place. And then when I hover over it, it displays the full name of it. And part of the reason we added this is when we run these machine learning runs, occasionally the tracker fails or the machine learning algorithm. And so we'll get a track that's populated with all these bounding boxes, and then there'll be a gap of some duration, like a minute, where there's nothing. And by adding this, it allows us very quickly go through and see, the machine learning did not produce data at this portion. We can rerun it with some different parameters. We have a little service I wrote. It's called Pythia. I'm going to grab an image from the deep sea and upload it, and then I'll run an algorithm on it. And the machine will come back and identify things that it's seen in the image.
With all this machine learning in place, do you still need the researchers to do a lot?
Oh, yes, absolutely. Machine learning now has made amazing strides in the last few years in regards to visual identification. It's getting really good at inference. But in order for it to work, you need large training sets. So you need these images, like thousands of images of a thing that you want to identify that have been localized. So someone's gone and said, here's a giraffe, here's a car, here's a person. And those are easy to acquire for terrestrial things because you have these huge, public data sets like Flickr, and you upload your images to any social media now, and for sure they're using those to train machine learning. So we've got these great data sets. But when you go into the deep sea, you don't have that. There aren't just thousands of images of heterocone calcics laying around somewhere that you can use to train your models. And so that's a real problem, which I will mention that we are working on. We do have, as part of that problem, we've put together this organization and services called FathomNet. And the whole idea here is to kind of allow researchers to take their meticulously annotated images from the deep sea and contribute them as a shared resource so that all of us can use those for machine learning training.
Can you use the machine learning to find animals that are not recognized yet and ask for feedback, or Or do you really need the researchers to find the new species to gather enough info?
It is possible to use machine learning to identify things in video. We call these megalodon models. It's kind of a joke, but these are these mega models that are just, rather than going through and identifying the animals in the video, all it says is, here's something interesting. So we train on all these different types. It says, here's something that I think is interesting. And then someone can go back later and classify it. So it can assist us with finding images in the video. But some of the challenges we have, besides having enough images to do machine learning, is a lot of these species are just hard to ID. So benthic animals that live on the bottom, are relatively easier. We're doing pretty good with machine learning for those. But midwater is a challenge. This is Aegina. It's a kind of jellyfish in a corner, but they're all squishy. They're clear. This is just ROV moving through the water. And things are just small and tiny and don't show up well. The midwater is the largest habitat on Earth, and it's just really hard to apply machine learning to this kind of video. And we are working on it, but it's just been a real challenge. There's a shrimp coming up here, coming by. These are different kinds of jellies you see in the back. And of course, they're clear. They're all in various orientations. You can see this jelly swimming around. That's, I think, a Colobanema just going by. And just getting data sets like that can work with this kind of, to help machine learning analyze this kind of video is a real challenge. And it's a lot of work to generate them. And you really need experts that know what they're looking at. And there aren't that many.
You have this amazing system which you created for your research institution, which is a generic video annotation system. Is by making it open source, is it also used for completely different topics?
I don't know. So it's open source, so anyone can grab it.
Yeah, anyone can use it.
Yeah, and it's not, honestly, it's not super easy to get up and running. Because it's a bunch of microservices, you have to have someone who knows how to start Docker and set up Docker. We do provide, for groups that want to run it, we do provide this M3 Quick Start project, which tries to simplify it a bit. So there's just scripts in here to Docker start. So if you have Docker running, it lets you just spin up everything, all the services, the database, the web server, just with one command. So we try to support organizations like that. And the ones that I know that use this are all focused on ocean-related topics. I know Oregon State University is using it, CSIRO, which is the Commonwealth Scientific Industrial Research Organization in Tasmania uses it. The Deep Sea Animal Research Center in Hawaii uses it. These are places that I know use it. But occasionally you see interesting applications pop up from people who have used VARs to do their own work. I remember a long time ago, this was a previous version of VARs from many ages ago, and someone had gone through, and I think they had annotated like wind vector diagrams, because there are image annotation features in VARs. And they had, I don't remember all the details of it, but it was completely unrelated to deep sea research.
You mentioned a previous version, so this is a completely new rewrite of it.
Yes.
Was it the back end? Was it the front end? What did you change, or what needed to be changed?
So what we needed to change was, originally, for many years, when the submersibles went out, we were saving all the video on videotape. And so VARs would talk to these professional video decks using RS-422 for control and getting the timecode index into the video. So it was a very different system. And at the time, I think this, like I said, 2014, JavaFX was just up and coming. I think Oracle had just switched it over from F3, which was JavaFX script, to a real Java API, and they had bundled it up with Java 8. And it's like, oh, this is a no-brainer. We can just start using JavaFX. It makes total sense. And it was a dream to develop with. It's a really nice API. Things changed a little bit. Oracle stopped bundling JavaFX with the JDK. There's a moment of panic, but then they introduced JPackage and JLink, so we switched over to packaging that. So now we include the JDK in the app, which is great. That actually works really well. Anyway, so we did this rewrite in 2014 using JavaFX, and it's been great. And I was going to show you, this is our main annotation application, but we also have an image annotation version. We had some interns start about 2 years ago that wanted to do image annotation, and we wanted to store all our annotations in a common database. So one of the researchers came out to me and says, well, can you add some image annotation features in the new system to support us? And so this is about a week's worth of work. It was a very hectic week, but we have this little app that allows people to go through and open image sets that are already existing in vars. There we go. So these are some researchers doing some work at this octopus garden where these are brooding octopuses that just basically sit on their eggs for years at a time. We're doing just measuring some temperature around them. And then there's one of the octopus garden itself. With this tool, again, this is all JavaFX. Now they can go through and say, all right, I just want to mark all the octopus, so they can quickly go through and just click on them and generate these little point annotations. Or if you're doing machine learning, you want to generate these training sets, you could go through and localize. So you could draw little boxes around each one of these animals. And if you make a mistake, no problem. You can select the animals and then change it to something else, and it'll change the annotations. And there's line tools, of course. Oops. So you can draw lines. And, of course, the ever popular polygon. And then if you don't like something, you can just select them, of course, and delete them off the annotations. We can adjust different parameters of the image if you needed to help enhance it, if you want to highlight things. Yeah. And then, of course...
and this was created in 1 week, you say?
Yes. Where my cursor is, you can see it. There's a magnifier in the upper right that kind of shows what we're looking at to help them ID things. And that can be... The zoom setting can be tweaked on that to zoom in more.
Okay, I'm totally impressed, not only by the footage you have, thinking this is a submarine a few hundred or 1,000 meters under sea, but also how you interact between all these images and how you annotate it, and everything is stored in a backend. What is the main advantage from your point of view of using mainly Java and JavaFX for this whole system?
Well, now a little disclaimer. When I said JavaFX, like the front ends are JavaFX. Mm-hmm. Many of the services are Java, but there's also a very large dose of Scala. I really like writing services in Scala, which is still, running on the JVM. And the main advantage for me is just there's so many portability, of course. Although with Docker, that is less important these days. But I'm familiar with the language. It's very easy to write things. It's very performant. We have some staff who prefer Python, and Python services are okay, but scaling them is sometimes a problem. It's not nearly as performant as JVM apps. I don't know. I like Java. It's just easy to write, and especially in the last few years, they've made such tremendous strides in developing it. With the introduction of Loom with the virtual threads, records, improvements to Switch. It's converging towards Scala in syntax, so it feels a lot more functional. It's really just a pleasure to write with these days.
Any future plans? Or I guess this is a project in evolvement that you keep working on?
It is always improving. Our main thrust right now is we're trying to get to the point where we're having machine learning do the annotation for us, or at least in the most part. Machine learning, like I mentioned for the benthic dives, it does a pretty good job, but we do have a number of issues related to misidentification or things we call broken tracks, where it loses track of an object, and then you get multiple annotations for a single object, and it has to be cleaned up. And so there's a lot of work on that. So we're improving the tooling to help develop better workflows for that. But that's our main thrust right now is really pushing the AI space. It's made such huge strides that we really think it could be a valuable asset and speed up this annotation. This annotation process is very slow. On average, it might take an annotator 2 hours to annotate an hour of video. And that's on average. Some takes much longer. And so we have this backlog of maybe 2 years that we haven't caught up on. So we're still working on videos from 2023. And we would like to get that closer to almost real time.
Okay, so still a lot of species to be discovered somewhere in that footage.
A lot of species, a lot of analysis. We do these long-term time series where we go to the same place in ocean, and we assess the species composition over and over, and we do this through time, and that helps us track changes in the ocean. And with climate change occurring, there's a lot of carbon being absorbed by the ocean, and that changes the chemistry and a lot of other properties of the water. And we're able to track changes in what's happening in the ocean over time because of these tools.
I have to admit, I'm a bit jealous of your job. You've really found a perfect combination of doing development on a fascinating subject. So I'm really impressed with what you've done. I'm looking forward to what you will share on Blue Sky or whatever social media of what next versions will bring. And we will definitely include them in JavaFX Central, the links of the week. And maybe this is a shout out to everyone who has a project where they have where they need video annotations, that you can actually use this amazing tool and get in contact with you if they want to improve it or have some feedback or some help to get started. Because it's open source, so people can use it and improve it, I guess.
Exactly. And we like to help people get this up and running, especially people who are doing research. We really want, part of the goal of MBARI is to develop these tools, not just for ourselves, but to share them with the community at large, the researchers around the world. So we would be happy to work with you.